So when we look at correlation, this is just one test to kind of talk about tonight, but correlation, the word correlation is simply defined as a mutual relationship between two or more things. So that's pretty easy and doesn't scare anybody, hopefully. When you're thinking about kind of where this falls in the mathematical realm, we'll move into that for statistics. I like to just break it down to as low as I can go so I can make this really comfortable for myself. So this term correlation goes by lots of other nicknames. It's called Pearson's product moment correlation. It's called Pearson's R. It's just called R. It's sometimes called correlation coefficient. And sometimes I think people are trying to vary their language in their writing, but it can be a little confusing for us as we're novices. As we become experts, we're trying to figure out what are some of the differences among these. Spearman's is a different type of correlation that basically, like Kevin did earlier when he did the log scale, somewhat similar in that you rank order your information and you're able to kind of utilize Pearson's test once you've done it in this different way. So tonight we're just going to focus on Pearson's because I think that will be the best example for us to utilize. So what it's showing us is simply the strength of the relationship and the direction, if it's positive or negative. So look at the bottom left-hand corner there where there's the blue dots and the line. So this is just a standard graph, nothing really special or pretty, but what we see is we see a collection of dots and we see that they're kind of spread out, but they're maybe sort of starting to have a trend. And then there's a trend line across it that's going up. So that says to me that that's a positive relationship, but how positive? I would need to see that R, that response for the correlation. What is the correlation number here that would tell me how strong that relationship really is? So those range from -1, which would be a negative relationship, all the way through to 1. And if you think about a 1 graph, you could imagine what that would look like. Simply a line which all those dots are just right on it, right? It's just this really nice solid line. And here I'm seeing like, I have an idea that I hope that that's a relationship, but I'm not really sure. So that's why I have to run the correlation to be sure on that. So a couple examples that are here are just simply what's a positive relationship, usually height and weight for people. So as our height increases, our weight increases over our lifetime. And also just an example for a negative relationship could be if bird abundance is going down in an area, maybe chemical usage is going up. So again, just sometimes I have to draw out, and I enjoy kind of just writing these out really simply. What does positive look like? What does negative look like? And then what am I seeing from the data that I'm gathering? And the bottom right is just ridiculous, but there are a lot of these very funny correlations that are out there. You'll see tons of them. And this one is just simply showing that the same curve exists for civil engineering doctoral degrees that are awarded and mozzarella cheese consumption. So while I would like to be in the cheese part of that study, I think that the idea is just really interesting to look at, right? So my mom would say, common sense check here, right? Does this make sense? Well, all we're seeing is really that there's a relationship. We're not saying that it's caused by cheese is causing more civil engineering degrees to be awarded. So think about that as you look at your data and just always remember to just kind of do those common sense checks while you're looking through your information.